end of organic chemistry here, or at least these alkanes. Let's maybe continue talking a little bit about that, kind of a preview, if you will, and maybe I'll help you understand some stuff coming up here with it. So really, as I mentioned sort of earlier today, it's really important to really get down, really as soon as possible, those first 10 alkane, both names and formulas, because really, as I mentioned earlier, every single thing, every single functional group, all the rest of the organic chapters, and pretty much everything else really does boil down to coming back to these sort of first 10 that I listed there. And there's also, I think, a table a couple slides down the road from where we were there. Again, methane has 1 carbon, 2 carbons is our ethane. Our 3 carbons is our propane. Our 4 carbons is our butane. Our 5 carbons is our pentane. 6 carbons again is our hexane. 7 carbons is our heptane. 8 carbons is our octane. There we go. That brings us to 9 carbons, which is our nonane, and 10, which is our decane. So understanding the names of all these guys and how many carbons is really, really important for how you name pretty much everything. Since these are all alkanes, which are carbon-carbon single bonds, as you can see, pretty much everybody here ends in the ANE sort of situation. So one of the first sort of things that you do when you're going to sort of name an organic compound is really, as I mentioned, sort of find, and that's referred to obviously as nomenclature. And usually the IUPAC way of nomenclature is always to find the longest continuous carbon chain. And as we saw there at the very end, and as we'll see in a few more different examples as well as we kind of go through it, it doesn't necessarily always mean, again, just straight across. So as we saw in that last one, if you actually went straight and then went up and over, you actually ended up with more carbons in a row than if you just went straight across. So the main thing on that is, as I mentioned before, the longest continuous carbon chain, only rule is you can't back up. So you can't go back over any carbon that you've already counted. Again, you have to go in kind of one direction until you hit a dead end. And once you do that, that's really going to give you, as we'll talk about, really the base of the name. So that's going to give you really your base of your name. And really, for our purposes, that will match one of these 10 guys that are over here. So you're going to have this main part of the chain, which is that was referred to as the main chain. And it's going to basically match one of these 10 sort of names. And that really will be the base of your name. Once you find that, you will then have what are referred to as groups attached to the main chain. So we saw a second ago at the end there. Let's see. I'm trying to remember the one I made up here. Let me see. What was that? It was. We had. So we had something like this here. I think it's what I drew earlier. we have something like this. And as we saw earlier, our longest continuous carbon chain, again, not necessarily the straightest, came from this way here. 1, 2, 3, 4, and then again up to 5, and then over to 6. So what I'm sort of highlighting here in yellow was the longest, again, continuous carbon chain. I never went backwards. I went one way until I hit a dead end. And as we saw earlier, if you did just go, straight across here, 1, 2, 3, 4, 5, that is obviously less than what we just did there. 1, 2, 3, 4, 5, and 6 going through the yellow. So as we go through this guy here, as I mentioned a little bit earlier, going 1, 2, 3, 4, 5, 6, they're all single bonded. I come to my list and go, okay, 6 is hexane. And that really does give me the sort of base of my name, is that longest continuous carbon chain. Now, kind of off of this longest continuous carbon chain, there's sort of like branches, if you want to think about it. There are these groups that are attached, and these groups are not part of the main chain. And in this particular case, we actually just have one group that's here, and that is this guy right here. So this guy kind of in green is what is referred to as a group. And it's also what is really referred to as a alkyl group, as I mentioned there at the end. That basically just means a carbon containing group. It's a group because it's not part of the main chain, but it's attached to the main chain. What makes it a group is it needs the ability to really be able to attach to that main chain. This group guy here is based off of one carbon, which is based off of also these first 10 guys, which would be methane. Now, there is a difference between methane and that group that's attached. So let's take a look at methane by itself, which would have one carbon and 4 hydrogens. Now, if I wanted to put this methane where that group is, and I took it just the way it is, and I went and wanted to basically attach it there, could I do it? Can I do that? And the answer would be no, you really can't do that, because if I imaginarily connected it there with my dotted line, I would end up with 1 bond to carbon, 2 bonds to carbon, 3 bonds to carbon, 4 bonds to carbon, and 5 bonds to carbon. And as we talked about earlier today, carbon is all about only 4 bonds. So because this is methane, and really because it has the 4 hydrogens that are present, methane cannot attach in with those 4 hydrogens. So essentially what needs to happen is we need to kind of make room on that methane to allow that carbon basically to attach in. And the way we're able to do that is basically it becomes a group where, although it has 1 carbon, it actually ends up with only 3 hydrogens. And because it's an alkyl, ends in YL, we drop the last part of methane, and this becomes a methyl group, YL. Based off of methane, has 1 carbon less. I'm sorry, 1 hydrogen less. And because it has that 1 hydrogen less, it now has the ability to bond into that carbon through that missing hydrogen. And that's why it's able to actually make that bond. When it does, the carbon now has 1 bond, 2 bonds, 3 bonds, and 4 bonds, which is perfectly fine for our carbon. So these groups, not 100% of the time, but these groups that are attached to the main chain are also based off of these first 10 alkanes. And the only difference is these alkyl groups we'll have one less hydrogen than the alkane. And it's that one less hydrogen that allows the carbon to bind in and not have too many bonds. Any questions on that? You could do the same thing with ethane. If you take away a hydrogen, it becomes an ethyl group. Do the same thing with propane. If you take away a hydrogen, it becomes a propyl group, and it gives it a way to basically attach in. So when we would do this, we would take our longest carbon chain, gives us our base name. We would look at the groups attached, and in this case, we have a one carbon group where we drop the A and E, put the YL, and that gives us our methylhexane. And as I mentioned at the very, very end, really sort of organic nomenclature is all about just telling people exactly where everything's located. So once we sort of find the longest carbon chain, once we find all the groups that are attached to that chain, the next thing that you want to do is actually number. Go here, maybe. You want to number the longest carbon chain. And the way that we want to number is to give the groups the smaller number. So what I'm going to do here is, flip page. I'm just going to redraw what I got going on there in the center. So we'll look at our guy again here. The guy we had. So again, up to this point, we have our group that's attached. We have our longest carbon chain, which rolled from here 1, 2, 3, 4, 5, 6. And at this point, we have a lot of our name. We have our hexane from the longest carbon chain. We have our methyl for our group. Now, though, as I was mentioning, what we want to do is basically number the longest chain, which in this case is in yellow. And there's really two ways you could go about numbering it. You could number left to right. So if I do that, that is 1 carbon, 2 carbon, 3 carbon, 4 carbon. And again, we're numbering the carbons here. So 5 carbon and 6 carbons. The other option is I can number right to left in this case. So starting right to left, this would be carbon 1, this would be carbon 2, this would be carbon 3, this would be carbon 4, this would be carbon 5, and this would be carbon 6. Now, what I'm looking at is the group that's attached here. And if I went sort of in the blue direction here, my methyl group would be at carbon number 3. If I went in the red direction, that methyl group would be at carbon number 4. So when we are numbering the chain, we always want to go with the lowest number. And in this case, it would be the blue direction, would be the correct way of numbering this chain. Once you decide which way you should number, which again is the way that gives the groups here the lowest number, you want to maybe get rid of the other way of numbering. Everybody else would be numbered accordingly. And in this case, obviously, we only have one group there. So We do to give the location of where that group is located, and that would be at carbon number 3. And this would be 3-methylhexane would be the name. When we name things, a couple of things happen. First off, we always put a dash between a number and a letter. Hence the dash here between the 3 and the M. We put a comma, say parentheses, we put a comma between two numbers. So if we had two numbers that went back to each other, we would put a comma between them. If you have a number and a letter, we put a dash between them. So longest carbon chain, find the groups, give the number of the groups, and the groups go in alphabetical order, regardless of number. So, if you had more than one group, you would put those groups in alphabetical order, again, regardless of the number. If you have more than one of the same group in the molecule, not necessarily at the same carbon, but in the molecule, we do use prefixes like di for 2, tri for 3, tetra for 4 to indicate, how many we had. Any questions on that there? So let's take a look at one here. Let's do just to kind of show you that. Let's do this there. Let's take this kind of the same deal. So just to show you about sort of the prefixes, let's take a look at this guy real quick here. Actually, you know what? Why don't you give it a go and see what you come up with? So try to follow those rules and see what you come up with in terms of this name that I just made up drawing. So why don't you give it a try here? So take a minute or two and try to give the proper name, try to follow those steps that we just talked about, and then we'll go over it together here in just a second. Okay, let's take a look at this one. Kind of similar to the last one we did. Again, the first thing you want to do is you should really try sort of all of your options in terms of trying to find the longest continuous carbon chain. Sometimes just straight across is good. So that is 1, 2, 3, 4, 5. We then could try straight across and down, 1, 2, 3, 4, 5. So that's 5 going that way. We could also go obviously here. Could start here and go 1, 2, 3, which is definitely short. We could go up here 1, 2, 3, 4, which is also less than 5. So none of those look good. We are going to end up in the same things we had previously here. So we had 5 as our longest in multiple directions. But here, though, if we end up with going from our left here, 1, 2, 3, 4, again, up 5 and 6. Again, here we do end up obviously very much like the last one there with 6, not always the case, but it just shows you do want to try multiple ways. And by the way, if it happened to have been 5 was the longest and there was a couple different ways to do the 5, sometimes the straightest is the easiest to sort of recognize what's going on here. So obviously right off of that, much like the last one there, we got 6 carbons. That gives us our base of our name as hexane. we then want to kind of locate what we got going on in terms of groups that are attached. And in this case, we actually have our CH3 that we saw before and another CH3 over here. So we actually have two of those one carbon groups, which is based off of methane, but because they are a group, this is a methyl group and this is a methyl group. And that's actually two methyl groups within the same molecule. So this is what I was talking about a second ago, that we do use a prefix. This would be dimethyl hexane. Putting it together here. The last thing that we want to do is our numbering, and much like the last one, we can number left to right or right to left. And in this case, again, if we went left to right, 1, 2, 3, and we're numbering the carbons again here, 4, 5, and 6. And obviously, if we went the right-hand way, in this particular example, will come out the same. 1, 2, 3, 4, 5, 6. We see that not just one methyl group's at carbon number 3, which is the smaller number than 4, but the other methyl group is also at carbon number 3. And sometimes people have a difficult time with this aspect of it. Even though they're on the same carbon, you do need to give the number twice. So this would be 3, 3, comma between two numbers. Both threes represent the location of where we find the methyl groups. And then we lay our dash between the number and the letter. And this would be 3, 3 dimethyl hexane. Question on that name there. So even if they are on the same carbon, you do need to give the number if they're the same group. The die here is not because they are on the same carbon. The die here is because there's two methyl groups in the entire compound. So, you know, if the other methyl group was on the other end or something, it would still be dimethyl. Question on that there. All right, so let's try maybe a different sort of one here. See how we do here. Just gonna start randomly drawing some carbons. Let's go this way. Let's go this way. Let's go this way. Let's do that. All right, let's do this. Let's do that. Let's do that. Let's do this. Let's do that. Let's do that. And let's do that. Let's do that. And one of those. All right, give it a go here. We are looking for the name, so try to follow those steps and see what you come up with. I'll do it as well since I just made it up. Hopefully it's all right. Okay, let's take a look at this one. So again, first thing we want to do is longest continuous carbon chain. So let's take a looky here. We could just go straight across and see. So that is 1, 2, 3, 4. Not bad. We could go straight across and go up. 1, 2, 3, 4, 5, 6. So that is more like we did previously. We could go from the left there, 1, 2, 3, 4, and down. So that's less than 6. We could start on the right here and go 1, 2, and up, 3, 4, 5. So that's less than 6. We could go on the right here and go 1, 2, 3, and then down 4, 5. Lastly, we could maybe start at the bottom here and go 1, 2, 3, 4, 5, 6, and 7. So actually the longest continuous carbon chain is 7, I believe, coming this way. That is, I think, 7 carbons in a row here. Any questions on that? So again, you sometimes want to make sure you kind of try all your options, not just go for the one that you maybe think is the longest. And that would definitely be 7, it looks like there. 1, 2, 3, 4, 5, 6, 7. That gives us the base of the name being heptane off of 7. Now we want to find our groups that are attached. So in this case here, we got group right here. And we also have a group right there. They are each, again, 1 carbon groups, which means that they are based off of methane. But because they're a group, we put the YL at the end. So they are methyl groups. Any questions on that one there so far? There are obviously 2 methyl groups within the same compound. So that gives us a dimethyl situation happening. So far, we got dimethyl and heptane. The last thing that we want to do is number the longest continuous carbon chain. Again, we have 2 ways. We could go right to left or left to right. So we'll start up here on top. And that would be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, and carbon 7. So going in the red direction, we have a methyl group at carbon 4 and carbon 5. If we number the opposite way, starting sort of at the bottom, if you will, 1, 2, 3, 4, 5, 6, and 7, we have a group going the blue way, a methyl at carbon number 3 and carbon number 4. So we want the smallest, which means that is a winner there. So we would want a number in the blue direction. And it does give us a methyl group of carbon 3 and carbon 4. Putting all those guys together, that again is 3, 4, comma between the 2 letters, dash dimethyl heptane. Any questions on any of those sort of steps there? So again, the important part is making sure you can kind of get that longest carbon chain. Make sure you get that continuous chain going on there. Any questions on that there? Let's try one more here going this way. Let's see here. Let's do that. All right, so once you give this guy a go, see what you come up with in terms of a name. Do it as well. Hopefully we end up the same slot. Actually, my bad here. Let me just fix something real quick. This guy actually only has 2 hydrogens there at the end. Okay, let's take a look here and see. Again, want to start with that longest continuous carbon chain. Color here. Might as well always shoot straight across and see. So we got 1, 2, 3, 4, 5, 6, which doesn't look too bad. Other options here is we just go here and go 1, 2, 3, and then down 4 and 5, which is obviously less. So that's not good. We could also have gone from here 1, 2, 3, 4, 5, and 6. So in this particular case, 6 looks like a winner, no matter sort of which way you went there. So 6 carbons, the base of that name again is going to be hexane here. Personally, if you have the choice and you can do it either way, I would probably take the straighter guy there and go with that as your longest continuous chain. So if we did that, that would then encompass everybody here. And this would be our continuous carbon chain of 6. That then means we got some groups that are hanging off of here. In terms of our groups, we actually have a bromine here, and we have actually a 2 carbon group that's here. So let's start with the 2 carbon group. 2 carbons is based off of ethane. It's missing a hydrogen to allow it to connect. So ethane becomes a ethyl group, YL at the end of it. This is a bromine, and the way we name our halogens is we call it a bromol group. If we had a fluorine, it would be a fluoral group. If we had a chlorine, it would be a chloral group. If we had an iodine, it would be an iodo group. So they're kind of like an O sort of at the end of the halogens. So we have a bromo group, we have an ethyl group. The last thing we want to do here is a little bit of numbering action here on our chain. Again, we got 2 ways to go. We'll go left to right here, which would be 1, 2, 3, 4, 5, and 6. That means in this case, we have a group at carbon 3 and carbon 6. We are going to then number perhaps the other way. This would be 1, 2, 3, 4, 5, and 6. Going the other way, we have groups at carbon 1 and carbon 4. It is as simple as 3 is larger than 1 or 1 is smaller than 4. We should go the blue direction here. So we do want a number going in this direction. Any questions on that so far? Because we chose going right to left, that means that carbon number 1, that is where my bromol group would be. So that would be 1-bromol. Carbon number 4 would be where my ethyl group would be. That would be 4-ethyl. And we go alphabetical here on the groups. So this would be 1-bromol, 4-ethyl, and then the base of our name, which would be hexane. Dash between number and letter, dash between letter and number, dash between number and letter. Any questions on where that name came from? All right, so just to kind of finish up here, one last thing. So we kind of done sort of formula to name. Let's talk about if you were given sort of a name and you wanted to draw the formula. So let's just say you had a name given to you of, I don't know, we'll go with, let's go with 3-ethyl. We'll go 3-ethyl, 4-propyl octane. We don't need the dash in between there. I'm just making this name up. I'm probably going to regret it here in just a second, but we'll go with octane. I think that should work. All right, there you go. So 3-ethyl, 4-bromol octane. And sometimes when people are given the names and they're given long names and they're asked to draw like their condensed formula, we'll do our condensed formula. It's actually the easier thing of everything is actually to draw something from a name. 100% of the time, when you are drawing something from the name, you should always work backwards in the name. And what I mean by that is we will dissect the last part of the name. That is octane, which means octane is 8. That means I should draw 8 carbons. And really what I should start with is just simply 8 carbons in a row. And 8. Not gonna worry about anything else but getting those 8 carbons in a row, and that takes care of that part of the name. 4 propyl means that at carbon number 4, there is a propyl group. Propyl comes from propane, which is a 3 carbon group. The nice thing about this is since you are drawing it, you could start numbering 1, 2, 3, 4, 5, 6, 7 that way. Or you could start numbering 1, 2, 3, 4, 5, 6, 7 that way. I personally am going to go left to right. So I'm going to start numbering in that direction, which means for me on the left-hand side here, this would be carbon 1. Next to it would be carbon 2. Next to it would be carbon 3. Next to it would be carbon number 4, which I know has a propyl group, which is based off of propane, and 3 more carbons. That takes care of that. Because I chose to go left to right, that is still carbon number 1, and that means at carbon number 3, there's an ethyl group. So carbon 1, carbon 2, carbon 3. Ethyl group is a 2 carbon group. Squeeze it in there maybe. And actually, you know what? I'll put it on the bottom so it's not so crowded. It doesn't really matter. You go on top or bottom. I'll throw it on the bottom there so it doesn't look so crowded. So we'll go here, carbon 3, 1, and 2. That takes care of this. That is really the basis of what I need to draw, but I am not complete yet. Everything else here is going to be hydrogens until carbon has 4 bonds. So how do we count that? Well, we look at the carbon we're going to add hydrogen to. This first carbon up here in the top right has 1 line coming in, which means it needs 3 hydrogens. That gives it 4 bonds. Carbon next to it has 2 lines coming in, which means it needs 2 hydrogens. Carbon next to that has 2 lines coming in, which means it needs 2 hydrogens. Carbon on the middle here has actually 1, 2, and 3 lines coming in, which means 3 bonds, which means it needs just 1 hydrogen. Carbon to the right of that has 2 lines coming in, needs 2 hydrogens to get the 4. 2 lines coming in, needs 2 hydrogens to get the 4. 2 lines coming into that carbon, needs 2 to get the 4. Carbon at the end has only 1 line coming in, which means it needs 3 hydrogens to get the 4. Starting at the other end, 1 line coming in, needs 3 hydrogens to get the 4. Guy next to it has 2 lines coming in, needs 2 hydrogens. Guy next to it has 3 lines coming in, needs 1 hydrogen to get to 4. Guy on the bottom, 2 lines coming in, needs 2 hydrogens. And finally, the guy at the end there needs 3 hydrogens. And there would be our crazy looking formula there in our condensed formula. So actually starting going from the name to the formula is pretty simple, kind of going backwards. Draw with sometimes referred to as just the carbon skeleton, just the carbons, and then basically fill in everything else will always be hydrogen, however many you need to get carbon basically to 4 bonds. Any questions on that there? Okay,